Hey everybody, today we are talking about special cases of lines that we've been studying. And the first that we saw recently when we were playing around with the death ray, as we call it, is a flat line. And a flat line, like what we looked at in this case, we've got this line. Oh, I don't need to draw that. That's horrible. So let's just actually get the computer to do it. So here is a flat line. And we saw that this represented someone who was standing still, that they were trying to stand completely still, and the calculator, or the death ray and the calculator, made this line. And we'll just take a look at a couple spots here. For example, these three spots. This was the x-axis, as you recall, was time. The y-axis was distance in feet. So this point right here, 1, 4, because this is 4 feet away, and then this 2, 4, that represented, for example, in the first point, that at 1 second away, the person, or at 1 second into the data collection, the person was standing 4 feet away from the death ray, and at 2 seconds in, they were also standing 4 feet from the death ray. So that if we tried to make a slope here, that we'd have 1, 4, 2, 4, and 3, 4, and that the delta y was 0, the delta x was 1, so that if we tried to make our delta y over delta x, then we'd have 0 over 1, or 0, so a slope of 0. And that coincides with, as we said in class, the fact that this person not moving has a speed of 0. And if we were to try to write this equation, then what we would come up with is y is equal to delta y over delta x, 0, times x. And then we'd have to find out if that works. So we'd try it. 0 times 1, back to my table, 0 times 1 is 0, but that doesn't match the y value, so I'd have to make it match by saying plus 4. And let's see if that plus 4 works everywhere else. 0 times 2 is 0. Plus 4 is 4, so that works. And then 0 times 3 is 0, which doesn't match. But if I put in the plus 4, I get 4. So it looks like this is my equation, 0x plus 4. And just to simplify it a little bit, I'm going to say that 0 times x is 0, just leaving me y equals 4. And that is the equation of this horizontal line. So that if you see any equation that looks like y equals, then what you can do is just know that that is a horizontal line. For example, y equals 2 is going to be a flat line, horizontal line, at the place where y equals 2. And again, that represents somebody standing still, not moving, a speed of 0. And the way that you could look at this logically is to say that this equation, y equals 4, is telling me that no matter what the, just to highlight here, no matter what the x value, 1, 2, or 3, the y value is always going to be 4. So that's what it's saying, y equals 4. Sorry about that, Bell. So again, it's saying y equals 4 all the time. Going back, or now going forward to our vertical lines, x equals 5. What we were trying to do in class is we were trying to create a situation where with the death ray, somebody could make a straight up and down line. No matter how hard we tried, we had people running fast, we had the trick with getting the hand out of the way, and it just wouldn't seem to work. And that's because if you look at this line, it's telling me that this point right here is 5, 1. This point right here is 5, 2, and then 5, 3. So that what that's saying is that, again, if I go back to x values, or x-axis being time and y-axis being distance, then it's saying that for example, this first point, at 5 seconds into the collection, data collection, they were 1 foot away. And now, looking at that for the second point, it's saying that 5 seconds into the collection, they were 2 feet away. So in other words, it's saying that they have to change distance away from the death ray at an instant in time. So they're at 2 places at the same time. And so that obviously cannot happen. If we look at that in a table and try to write our delta y, delta x, so I've got 5, 1, 5, 2, 5, 3. My delta y is plus 1, delta x is plus 0. And that means that my delta y over delta x would be 1 over 0. And if you plug that into a calculator, it's going to tell you that that thing is undefined. So a slope being undefined. Think of this problem. The slope was 0, in essence saying his speed was 0. Here, this speed just doesn't even make any sense. It's not logical to say that you'd be in 2 places at the same time unless you're some sort of superhero. So therefore, this person's slope is undefined. Okay, so how do we write an equation if we don't have a slope to even test out? Well, let's think back to this equation where, logically speaking, we said that if right here, if y equals 4, that's telling us that no matter what the x values, the y values are always 4. So let's apply that same logic here to this table. And what this is saying is that no matter what the y value, the x value is always 5. So that is our equation where that comes from. X equals 5 is it's saying it doesn't matter the y value, the x is 5 all the time. So anytime that I see just a one variable equation, I tell kids just think about the words all the time after, and think about the death ray like we did in class. X is 5 all the time. Or here, y is 4 all the time. Okay, and think about the death ray in these tables. So that if we were to graph let's graph another equation where this time, let's say x equals 3, then that would be x is 3 all the time. And you could make a table if you wanted, or you could just, if you knew that was a vertical line, it would be right here at x equals 3. 1, 2, 3. Okay, that's it for vertical and horizontal lines. Learning targets 9 and 10. We'll see you in class.